the continuation of the topic, heat energy. We want to see some calculations under it. I'm Nwachukwu Daniel. Please, if you have not subscribed to my YouTube channel, please endeavor to do so. I so much appreciate. Okay? Now, we have 3 questions to solve on it. The first one said a copper of mass 0.2 contains 0.08 kilogram of water at 20 degrees Celsius. Lead shot of mass 0.1 kilogram at 90 degrees Celsius is rapidly confined to the water. As we know heat loss to the surrounding, calculate the final temperature. Now, what should come to your mind if you see a question on heat is heat loss equals to heat gain. Now, which one is losing heat and which one is gaining heat? Remember, heat is transferred only from hotter substance or hotter object to colder object. Okay? Now, from this question given to us, you will see that the lead shot has a higher temperature, 90 degrees Celsius. That means lead shot is the one losing heat. So, we remember our formula for heat is mass of the lead, specific capacity of the lead, and change in temperature. Then which one is gaining heat? Is it only water or is it only copper? Which one? Now, to understand the one that gains heat, use this scenario to understand it. When you have an iron bucket, when you bring an iron bucket and you pour cold water inside it, now you bring a very hot water, a very hot or very boiled water, and you pour it inside that cold water inside the iron bucket. What will happen is that after pouring that hot water inside that cold water, you notice that the side of that iron bucket will be hot. It will be very hot. It will be hot the way the water itself is hot. So it is both the water and the iron bucket that will gain that heat. Do you understand it? And that is why it is said that metals are conductors of heat. If you are using boiler to boil your water and you carry your boiler and put inside an iron bucket full of water, there is possibility that it may shock you or it will shock you because the iron will conduct heat from that boiler and it can shock. Okay, so iron or metals do conduct heat. So both the water and the iron are the two objects or the two substances that will gain the heat. And both of them will gain the heat to look at the temperature of the water. Since the temperature of the water is 22 degrees, it means that invariably the temperature of the water and the iron is 22. So, since we are talking about the copper now, copper is also a metal. It means that the temperature of the water and the copper is 22 degrees Celsius. Now, the temperature of the lead is 90 degrees Celsius. This is for the lead. As you put this lead inside this bucket of water, the water will gain heat, so the lead will lose heat to this temperature, while this water will gain heat to this temperature. And that temperature will be called the final or the equilibrium temperature. The temperature where these two, the temperature where both the water, the copper, and the lead will have the same temperature. So once you put this inside that water that is less hot, it will absorb the heat. In essence, the copper will also absorb the heat, and both of them will be having, all of them will be having this final temperature called final or equilibrium temperature. So the heat lost by this lead is gotten from 90 minus theta S, where the temperature lost by this water and copper is gotten by theta F minus 22. That is the temperature loss from here to here. This is the temperature loss from here to here. Then the implication is that the copper and the water are what will gain the heat, because copper is a good conductor of heat. So if we gain heat, water also will gain heat too. So what will happen now is that, what is mass of the lead? You say that mass of the lead is given to us as 0.1 times specific capacity of the lead is 130 times change in temperature. Change in temperature we have is 90 minus theta F equals to mass of copper is 0.2 times specific capacity of copper is 390 plus mass of water is 0.08 and specific capacity of water is 4200, all times theta F minus 22. So this times this will be giving us 78. This times this will be giving us 336. This times this will be giving us 78 plus this times this will be giving us 336, then bracket theta F minus 22 equals to this times this will be giving us 1170. This times this will be giving us 13 theta F. So 0.1 times 130 will give us 13. 13 times theta F will give minus 13 theta F. 0.1 times 130 will give us 13. 13 times this will give us 1170. Now this plus this will be giving us 427 theta. 427 theta F. This plus this will give us 414 theta F. Then this times this will also give us 41 minus 414 times 22. Then 1170 minus 130 theta F. Now what will happen now is that this will cross the other side. 1170 plus product of 414 times 22 equal to 414 theta F plus 13 theta F. If you add this thing, it will give you 427 theta F. Then if you multiply these two and add it to this, it will give you 9450. So it said therefore theta F will be equal to 9450 all over 427. That will be giving you, when you divide, it will give you 22.17 degrees Celsius. So that means that when you put this inside this cold water, they will get to the temperature of 22.17 degrees. So the temperature of the water will increase to 22.17 degrees, while the temperature of the lead will reduce to 22.17 degrees. That is the answer for the final temperature or the equilibrium temperature. We go to the next question. There are many ways you can supply heat. There are many ways you can supply heat, hence get the specific capacity. You can supply heat by electrical method. You can supply heat by mechanical method. You can supply heat by continuous flow method. And you can also supply heat by mechanical method, electrical method, continuous flow method, and so many other methods. So even if you use firewood or gas cooker, you are supplying heat. So that is mechanical method. So these ways of supplying heat are also ways you can also get the specific capacity. Now in this question number 2, the heat is supplied by electrical method, and that is why they say an electric current 3 ampere flowing through an electric heating element of resistance 20 ohm embedded in 1000 grams of an oil raises the temperature of the oil by 10 degrees Celsius in 10 seconds. Calculate the specific heat of the oil. When you are supplying heat by electrical method, remember the formula IVT, that is the electrical energy, is equal to I square RT is equal to V square over RT. These are formulas for calculating the electrical heat energy. So you equate it to the normal formula you know, MC theta, where the T must be in seconds, the R in ohms, the voltage in volts, the I in amperes. Now, since they gave us I to be 3 amperes, resistor to be 20 ohms, T to be 10 seconds. The implication is that we use this formula. So it implies that I square means 3 square times R means 20 times 10. You say it's equal to, what is the mass of this? The mass is given to us in 1000 grams. Now, 1000 grams, convert it to kilogram. 1000 divided by 1000 will give you 1 kilogram. So 1 kilogram times C, which we are looking for, the C of the oil, times the temperature. The temperature is 10 degrees. So what will happen now is that you say 3 square, 9 times is 180 times. This will cancel this. This will be giving you CO equal to 180 joules per kilogram per Kelvin. So as you make this subject of formula, 1 kg will divide this. After we divide it, so it will be giving you 180 joules kilogram per Kelvin. This is the specific heat capacity of the oil. Now we go to the last question that says, a piece of copper having a mass of 3.2 kilograms at room temperature of 16 degrees Celsius is to be melted, which require a temperature of 1080 degrees Celsius. In latent heat of fusion is this, and specific heat capacity is 380. How much heat energy required to melt the piece of copper? Note that every metal, every substance has its latent heat of fusion. What do we mean? It means that for you to melt any metal or any substance, there must be a particular temperature you must reach before it can melt. For water, we say it must reach 0 degrees Celsius. Now, they say for you to melt this copper, you must require 1080 degrees Celsius. It means that the melting point of copper is 1080 degrees Celsius. So we now say you move from, they say it required temperature of 1008. You say mass of the copper times C of the copper times temperature plus latent heat of fusion. Why do we say plus latent heat of fusion? When you melt a particular substance at its melting point, at every melting point of a particular substance, so for instance water 0 degree, at 0 degrees that ice block melts to water. The implication is that MLF must act on it. It is a hidden heat. Now, since the melting point of the copper is 180 degrees, the melting point of water is, the temperature required to melt the copper is 1080. The implication is that if you check it very well, it means that 1080 plus 16, that will be giving you 1096. That shows that the melting point of copper is 1096. That is, as the copper is 16 degrees Celsius, it has to move to 1096, and that is how they got this total temperature to be 180. Temperature required to move from here to here, which is the melting point. Then you say at 1096 degrees Celsius. That is, this will add on it. This one, MC, change in theta will add on it. What are we saying? Since the question says that the copper is 16 degrees Celsius and it used a temperature of 1080 to melt it. It means that 1080 plus 16, 1096, that is the full melting point of copper. That is, for you to melt copper, you must move from 16 degrees Celsius to 1096 for you to get the change in temperature to be 1080. That is the temperature required to melt it. So, as it is 1080 now, what matters now is that you multiply it to spinning capacity of the copper, which we said is 390, times the mass of the copper, 3.2. Then, as you get to 1096, latent heat of fusion will add on it, which is mass 3.2 times 334. Latent heat of fusion of copper is given to us to be 205,000. It's given to us. Latent heat of fusion of copper is 205 kilojoules. Kilojoules mean 205,000 joules. So kilojoules mean multiply this by 1,000, you get it in joules. So the spinning capacity of the copper is 380, please, not 390 here. They gave it to us to be 380 in the question. So the one they give you in the question is the one you use. Don't use your own constant. Then, when you multiply these two and add, if you multiply these two, it will be giving you 1,313,280. When you multiply it very well, then plus, when you also multiply these two, it will be giving you 656,123. 656,123. That is 3 zeros. 1230. Now when you add the two, it will give you 1969,280. 1969,280 joules. So this means that this is the total heat required for you to melt a copper that is in 16 degrees Celsius. Melt it very well after requiring a temperature of 1080. So this is the total heat required for you to melt this copper that is 3.2 kilogram. Hope you understand the topic. So every metal, every substance has its melting point. So you have to know the melting point of that substance. Once you know it, that will help you to know what is the point that the latent heat of fusion will add. As far as you know the melting point of the substance from the question, it means that we have known where the latent heat of fusion will add. So after you use 3.2 multiply to 380 multiply to 1080 with your calculator, then say 3.2 times it, which is the latent heat of fusion where it adds. After you add the two, you get the total melting, the total heat required to melt that substance, so to speak, copper. Okay? So thanks for watching the video. Please don't forget to subscribe to my YouTube channel. Also comment and like the video. See you next time.